This is Seung Kim. Today, I will talk about uh, Candle. Candle is Rust AI library, which is provided by the Hugging Face. So I will compare to how to use Candle and how to use PyTorch. Actually, Candle follows a lot of concepts in PyTorch. So how it is similar and how much they are well organized together. And I will show you that the similarity and the little difference. So let us start. Uh, I'll talk about first Python, PyTorch. PyTorch is based on Python, right? So in Python, we have to import PyTorch. The PyTorch actually we import by torch. So we use import torch. That's enough. And we want to test the basic functions today. So how these basic functions can be differently implemented in the Candle from the comparing to the PyTorch. So actually the basic function is define the tensor. It's easier. We make like this. We put the torch tensor, and this is the list notation in Python. So this is 2 by 2, 1, 2, 3, 4, 2 by 2 matrix. We can make it. And also we can make a zero matrix, all zero. So in this case, we can provide a dimension. So 2 by 2 dimension is the size of zero matrix. Now is matrix is like this, 0, 0, 0, 0. Also, we can make a tensor matrix 2 by 5 like this. So we provide the list for this. Then we can say that this is torch tensor. And also we can slice them. It's easy. It's very much similar to the NumPy. So if we want to end up the fourth element, then you can describe like this. So it's very easy. So even if it is ended 4, but we specified it should be ended until fourth element. So it's only 3 is come. So also we can change the shape using the view. So the view 2 by 2, 2 by 2 is here. So this is 1, 2, 3, 4. So originally its dimension is just 1, but we can change the dimension using the view. This is a little bit strange comment, but we use view in torch. That's okay. And also we can make a torch 2 tensor. A is 1, 2, B is 5, 6. And we can multiply them. This is matrix multiply. So A dot mat B. So that's the matrix multiply. So we can get the 17, right? So this is matrix multiply. And also we can do addition. Addition is similar, but their dimension and the shape should be the same. So we can say view here because this is PyTorch. So 1, 2, 3, 4, and 4, 5, 6, 7. It's they are added 5, 7, 9, 11. And also we can change it there the type. Actually, I made it as an integer, but it automatically become float. So we can make like float 16. So this is 1, 2, 3, 4. That's the one of the solution. And also we can save tensor. Save tensor is easy. We can use torch.save. Then we can save a torch. But here we have to use the dictionary, right? So we have specified the name of the tensor. Here is the A, right? And also we have to provide the name of file. So tensor.bin is the file name. So we can save like this. And so we can get the weight from the saved one. So we use load. It's easy, right? So we just provide the file name tensor bin. So we can get a weight. So much intuitive, right? So we calculated or we calculated, and then we saved the weight, and we also reloaded the weight. That's all, right? Except we didn't do the how to make a model and how to train them. We didn't do that, but we will do it later because but those are very basic command, so it's also important. Let us start similar candle. Candle is Rust, right? Rust candle command right now. Different from the interpret language. Well, when you want to use Torch, we have to install using PIP, right? PIP, Torch, something like that. But this is compile language, so we have to use dependency. We have to do that in the toml file, but cargo toml file. But this is interpreter. Jupyter. Actually, this is not interpreting. It's pretending like interpreting. So we have to specify the what kind of library we will use. Actually, we will use Candle Core. So in the compile language, Candle Core is abbreviated to the Candle, but here you can specify exactly Candle Core. And the Candle Core can include the type, device, result, tensor, index, OP. So we can take this to use later. Also, we use hash map. Hash map is, I mean, we need it later because I show you in PyTorch, we use dictionary in the saving mode. So here we use hash map. So now we start the basic function, right? How to generate the tensor. It was so easy in PyTorch, right? We just list off. Uh, Here is also similar, but as you know, that list type is so important. Right? This type increase the speed, so we have to specify the type exactly. Though in Python, it's automatically converted to the float, but no automatic converting is possible in a Rust because type is so important in order to protect the memory error. So I specified this value are float 32, and all the other members should have same formatting. So they are the also have to put the dot here. So to make them to float. And I have to specify where I have to save this value. So I have to specify the device CPU. So this will be saved the CPU because I don't use GPU right now. And yeah, this is result. Result can have a result type, okay, okay, or the error. So in order to unwrap the okay, we have to use this quotation mark, this question mark. So now we can print out tensor. So the result, as I show you, is the same, right? This is same. And also we can print it as a vector. We can convert it to the vector. This is also possible, but we generally don't need, right? So you use like this. So it's quite easy, but we have to specify the type first. And also we have to provide what kind of device you use. Those are different, except that almost the same. In Python, no need to specify this output, but here we have to do that. Next, we can define zero as well. So we can uh, make zeros right here. So this becomes 0. So type in the 0, we didn't provide the data yet, but the type is so important for the Rust when the new variable definition. So we have to provide what kind of type we will use. So we provide the D type F32 uh, before the device view. That we have to remind that in the Rust, if we don't provide the data itself, only dimension like this, we have to specify the what kind of data type use. That's the only difference. Yeah. And also, right now, we want to, as I said, slice the tensor. In order to slice tensor, we use I parameters, which is a little bit different from the uh, PyTorch. PyTorch, we can use directly the, the the lists or the numpy like slicing, but here we use I. This is important. Yeah, this follows list property. And the method is easier, right? We use these notations for the ranges in the list. But as you know, we use this column-based yeah approach. So that's the difference. But the others are the similar. So the results are the same, as you right. And they added the dimension and the types because those are so important. The dimension and type and also the characteristic of the variable. So in Python, we can ignore them sometimes, but in Rust that's important. So we have to they will specify these even if you print out print the variable. So that's the difference and the important factors. And also we can reshape that. The PyTorch we use view, right? View 2 by 2, but we use reshape. But the, the statement or grammar is almost the same, right? Reshape 2 by 2, view 2 by 2. Then the tensor will be change their view dimension. And if you want to multiply them, so in this case, it's almost same, but as I said, we have to specify the type, uh, explicitly. Uh, this 2 point is okay because 2 point could be the uh, F32 or F16. That's okay because once we specify this for the first element, the other element will follow it. So it'll be okay. And this is 1 by 2. So these calculation results are the same, but here we add 0 here. And also uh, we can do addition, but there is one difference in addition. If you add these two variables, then as you can see here, in the multiplication also the same. If you provide a b directly without referencing, then you cannot use b later. So if you want to use b later on, you must specify the reference type. Here as well, A and B should not be moved. So in that case, we can put the reference here. That's the difference. And we can also change the type by to D type, quite similar to D type, because D type can do both type conversion and also they can be changed in a PyTorch. So here we additionally specified what we want to do. So we want a D type change. So to D type and you specify the type here. And also lastly, we can save the weight or the tensor. So the candle core save tensors save is the saving method. And we provide a Hassi map instead of dictionary. Dictionary is not supported directly, but hash map is provide the exact functionality. So A is the name of the weight or the tensor, and we additionally provide the A as we did in the PyTorch, and we provide the name of uh, the weight. It is file name, right? So we can specify here the file name, and also we can also get load the file. We use also load the same, uh, the keyword like save and load. PyTorch they use the save and load. We use save and load. And the load, and we just provide the model name, but we have to specify whether it is what kind of device use. So we use CPU, so we can specify it here CPU. Yeah, so now we can check it out. The map A, because map can have different name. So we now have map A. So now it works, right? The almost same. Yeah. So as you can see, the candle provide the the equivalent, almost equivalent, not exactly, because they have different characteristic in language wise. So almost similar, almost comparable keyword for the basic functionality in Candle. Okay. So if you started to use Candle in Rust, if you have any experience in PyTorch, you will easily start. Although you didn't have experience PyTorch, when you make or write Candle code, you can refer to how to use PyTorch. This will be very helpful to you. Okay, I will wrap up today the lecture. Thank you so much.